This podcast is sponsored by Click Playground. This free programming environment lets you explore and test your data-driven app ideas using Click's engine and APIs. The goal? Less query writing and more efficiency with associative indexing. Visit playground.click.com to learn more and see it for yourself.
Welcome to the InfoQ podcast. My name is Wes Rice, and along with a committee of architects, senior developers, and engineering thought leaders from places like Netflix, Stitch Fix, Reddit, and a variety of other places doing amazing engineering, I chair and plan the content for the English-speaking QCon software conferences published by InfoQ. The next one, by the way, is QCon New York in Manhattan, June 26 through 28. The InfoQ podcast is an architecture-leaning podcast that chats with some of the engineers you typically find speaking at QCon or writing for InfoQ. In today's podcast, we talk with Richard Feldman, and it's all about Elm. Elm is a front-end focused functional programming language that compiles to JavaScript. In this very densely packed podcast, Richard talks a lot about things like being an early adopter of Elm, the architecture of Elm, Elm's immutability, timeline debugging, semantic versioning, package management, and more. He talks about community, ecosystem. I really hope you enjoy this podcast. It was a lot of fun. Richard, welcome to the InfoQ podcast.
Thanks for having me.
I went to your talk at QCon London. I was super impressed. I guess my second real exposure to Elm, and there were a lot of things in that particular talk that got me excited, like the debugging experience, for example. Yeah. Okay, so I'm really excited to learn more about Elm and ask you some specific questions from that talk and from some other things. But before we do, let's kind of set the stage. Tell us a bit about what the work you're doing today is and about the company so we can kind of learn about the problem space you're solving with Elm today.
Yeah, so I work for NoRedInk, and we make grammar and writing software for English teachers. So basically, the founder was an English teacher for 8 years, and he kept running into these problems where he was like, I can't solve these with pen and paper. I really need software to do a really good job teaching these concepts. So he hired a guy on Craigslist to build this software for him to use in his own classroom, and then other teachers started asking him about it, grew, and soon, eventually, he decided, this is what I want to do is I want to, build this out and turn it into a company. And about 5 years later, here we are. So we're now up to over 2 billion questions answered, millions more being answered every day. We've got a team of about 20 engineers. We're hiring, by the way, trying to grow that team and making money, and it's going really well.
So I just imagine from just the context of this being Elm and being a front end that it's a very front end heavy app. It's running mostly in the browser.
Yeah, definitely. About a quarter of our users are iPad, but we don't have a separate app. It's all just in the browser. And we sort of pride ourselves on taking a really customized approach to each different concept that we're teaching. We kind of view like multiple choice is the last resort. We always try to do something more interactive, more tailored to the individual curriculum. And so that means lots of custom UIs for all the different concepts we're teaching.
Cool. So you have Elm on the front end, I would imagine,
Yep.
Among some other things probably still. But what about the rest of the architecture? What's that look like?
The backend is almost exclusively Ruby on Rails. We just started introducing some Elixir services. We've got one in production. We're working on another 2. And basically, as we've sort of scaled up and up, we've started to run into certain limits. And the old approach of just a big Rails monolith isn't really scaling anymore. So we're pretty excited about Elixir 2 on the back end. And there's been a lot of talk about the Elm Elixir pairing going on. So happy to get on board that train.
Yeah, I was going to assume that it was Elm Elixir. That's why I asked you.
Yep.
So you mentioned just before we started recording that it's been about 2 years since you started this journey to Elm. What did it look like before Elm? And then I guess what kind of triggered you into picking up Elm and taking it into production?
Yeah, so before that, it was, you used the term earlier, JavaScript jungle, which I think is pretty accurate. I mean, we had just jQuery and some Backbone and a little bit of Angular and just a big mess of things. And then React came out in 2013, and I found out about it, and I'd been sort of into the functional programming idea. I hadn't really done much with actual functional languages, but conceptually I was like, this is a pretty cool way to write programs. And I heard about React and I was like, oh wow, this sounds really great. So we were actually really early adopters of React. I actually co-authored a book on React, like one of the really early books on React. And basically we had a really good experience with that, and that sort of became our dominant paradigm and sort of led us out of the jungle of all these different technologies and into the like, okay, React is what we're doing. But separately, I'd been kind of wanting to actually try a first-class functional language that was like designed from the ground up to be functional. So I ended up, for a variety of reasons, settling on Elm as the one I wanted to try. So I was using it for a side project. And basically, there came a point where we did a really big feature in React at work. And at the end of that feature, I was like, wow, this would have gone so much better if I'd used Elm with it, that I actually think, based on my experiences with Elm, it was kind of a mistake not to try doing it in Elm. And I regretted that. And I said, I knew better. I knew that, this technology was there and that it was good, but I didn't use it because it was kind of a new thing. I didn't really want to take a risk on it. And I thought, okay, well, fool me twice, shame on me. I'm not going to do that. Next time, I'm just going to try introducing it and see what happens. So we just tried it out on a really small feature, and it worked. It went well, and so we did a little bit more, and then before we knew it, that became our new dominant paradigm. It was like, yeah, this is what we want to do, and that's what it's been ever since.
You used a phrase in the talk, or a comment in the talk, where you said we could have taught everybody to use Elm and still delivered it faster than we had with React. That kind of stood out to me as a really telling statement.
Yeah, for sure. And I mean, a lot of that had to do with the feedback loop, where, this was a project where we needed to do a lot of heavy revision. Like we would try out a design, we took it out to a classroom, tried it out, and it just didn't work. It wasn't effective. And so we went back to the drawing board. And when you have to make a lot of big changes like that, Elm's really conducive to refactors, to rewriting stuff, because basically the typical experience is you make a bunch of changes and then you work through the compiler errors. And the compiler has these really friendly error messages that help you figure out, all the different corner cases you missed. And then once it recompiles, it typically just works. So it's no regressions. That's like a pretty normal experience. And it sounds kind of hard to believe when you use the JavaScript. It certainly was to me. But now I'm just, now I take it for granted. But basically, I kind of, had a very different experience with React. With, I would make these changes and I'd run it and I'd get a runtime exception and go trace that down and figure out what went wrong. And there was just a lot of, crashing into things until finally I hammered it all out and got another version working that we could take out to a classroom and try out again. And we had to go through several of these iterations. And by the end of it, I was like, this took so much time to revise that even counting the amount of time it would have taken to introduce Elm, to ramp people up on it, like by the end of the project, it would have ended up being a net time savings, and the results would have been more maintainable. Yeah. So that was how I knew it was a mistake not to use Elm.
Wow, that's crazy. So tell me something. How did you sell that to your leadership to be able to introduce Elm? I mean, this was 2 years ago. I just, maybe I'm late adopter to it, but I just found out about Elm last year sometime. So 2 years ago, that had to be even more of a challenge to try to sell it to your leadership.
So, the interesting thing is it really comes down to risk. And the key for us was just, we talked about it and we were kind of like, okay, so this is a new technology, it's not mainstream. The key was just saying, well, look, we're just going to do it on a really small project, right? Like this is just going to be one part of one page. If it doesn't go well, we can always back out. And if it does go well, we can say, okay, well, then we'll just do a little bit more and see where that takes us. So it's, a big difference doing it on a small piece of one page versus saying our next project is going to be in Elm, right? Then you're really betting the farm on it. And that's a big risk. And so if you can minimize the risk of introducing it, then it's not such a hard sell. It's not saying like, we're not committing to this. This is not a commitment. This is an experiment. We're just going to try it out and see where it takes us. And so this incremental adoption strategy is by far what I hear as being the most common way that other people adopt Elm. I mean, nobody told us to do that. We just happened to do it that way. And thankfully it worked out. That was what we did with React too. So we kind of had a little bit of experience with that approach. But basically, it seems to be a pattern where when I talk to people who are using Elm in production today, that's by far the most common way that they got there, was just starting with something low risk.
Makes total sense. Sounds like a lot like Lean UX, to be able to start with something small, test it out, minimize the risk, and then kind of iterate. If it doesn't work, you cut your risk and then iterate from there. Yeah, absolutely.
Exactly.
What is a really good use case to start with that someone who may be coming from the React community or from the Angular community or Ember community for that rec? What's like a really good use case that can show maybe the power of Elm for someone to start off with?
I'd say anything that you're sort of afraid to maintain. And now that is a bit of a double-edged sword, right? Because on the one hand, if you're afraid to maintain it, then maybe you're afraid to change it to something else. But I would say if the reason you're afraid to maintain it is that it's changing often, like you often find yourself having to go in and tweak the business logic, something like that, rewriting that chunk of the code in Elm, and of course, using Elm has JavaScript interop. So that would be the way that you incrementally introduce something, is put it in there and then have JavaScript talk to it, sort of Elm as a service. And then once you've got that in there, then you can just sort of use that as a way to get an experience with what happens when I need to maintain this chunk of the code base now. And my expectation would be that you'd find, oh yeah, this actually isn't scary anymore. We recently had one of our newest team members, and she's been working here, I want to say 2 months maybe. And she just, like earlier this week, she made a series of refactors that touched something like 115 files. And she just made a pull request and she's like, wow, I'm just not at all afraid that this is going to break anything because it all compiles. And like, the experience is just like, typically if it compiles, it just works again. And like, we have a QA guy, so we're not, just going to like shoot it straight into production, of course.
Sure.
But, just that level of confidence is just a real game changer when it comes to developer productivity.
Yeah, I was going to ask you, and I think you just answered it by saying that, but what the ramp-up period was. I'm imagining when you typically hire people, and I know this for a fact because your talk, but you're not hiring people that have this tons amount of Elm experience. You're hiring them that maybe from the JavaScript community or so, and then bringing them into Elm. And so the ramp-up period, within 2 months, you've got someone who's refactoring across the entire code base pretty confidently. That sounds like a pretty good ROI there.
Yeah, I mean, so we don't expect any Elm experience on day one. Like that's just not even part of our job requirements. And yeah, so we have people writing Elm in their first week. I mean, usually not making such a big invasive change to the code base, but honestly, that's less about Elm and more just about, how many companies hire somebody and then on their first week, they're like, make a huge refactor, you just don't know the code base well enough yet. But I will say that, it's been surprisingly easy to get people ramped up on Elm. And the key for us has just been pair programming. It's, sort of saying, okay, we're going to get you up to speed by just pairing with someone and they'll just explain concepts as you go. And you can build up a lot of good intuitions from that. And then once you do get on your own, the compiler helps you out a lot. Like if there's something that, once you've got sort of the basics down and, you don't know about this edge case, you don't know about this technique, in a lot of cases, you can just be like, well, there's sort of a guardrail around, what can go wrong because the compiler is going to help me out. Like if I try to do something crazy, the compiler is going to give me an error and then it'll usually explain to me, here's why this is a problem. Here's where you can go for more information on it. And so that gives beginners a way to sort of build stuff, be productive, ship stuff, get stuff done. Maybe in a pull request, somebody says, oh, actually, you didn't know about this other way you could have done this. Here's a cleaner way to do that. But the risk that they're going to actually break something or cause a problem is way, way lower than what it is in JavaScript or TypeScript for that matter.
Yeah, that makes sense. Okay, so let's back up for a second. So we kind of just jumped right in, but let's start off with what is Elm? Because, when I think of Elm, I think of it as a transcompiler, and I don't think that's accurate. So what is Elm?
Yeah, so Elm's a functional programming language that, as it happens right now, compiles to JavaScript, but there's absolutely no reason it can't compile to other things. But it's primarily focused right now on compiling to JavaScript and letting you use it to build reliable, delightful web applications. So it's sort of two-pronged focus is developer delight and maintainable applications, like really reliable stuff. And the key to both of those is basically the design of the language and the compiler that backs up that design. So the friendly error messages, the idea of getting all of your checks done at compile time rather than at runtime. We talked earlier about we've had Elm in production for 2 years now. We're over 100,000 lines of Elm code, and we still have gotten in production a total of 0 runtime exceptions in that entire 2 years.
What do you mean? So, undefined is not an object, nothing, you don't get those anymore?
Yeah, not at all. So we use rollbar to do error tracking. And so whenever something throws an exception, rollbar tracks it. And so we have still a lot of legacy JavaScript code. Like it's a minority of our code base now, but obviously, historically we wrote a lot of JavaScript before we started writing so much Elm. And so we still see runtime exceptions from our legacy JavaScript code all the time. So we know that they still can happen. We didn't all just become, magically amazing programmers.
Yeah.
And it's also not that Elm's design encourages swallowing errors. It's actually the opposite, where Elm's design really encourages handling errors. And so the key is basically that Elm's design is such that the compiler can catch all of these things for you at compile time. This is like an overt goal of the language to be really explicit about, here are all your edge cases. Don't leave anything up to just, oh, well, we'll figure it out. And if it turns out something's wrong, we'll just crash. That's always considered, not the right thing to do. And because the whole language, like all the primitives are built around this concept, other programs, or libraries that are built on this sort of solid foundation also inherit that same characteristic sort of by default. And a really good example of this is null. So you have, in Java, you have null pointer exceptions. In JavaScript, you have undefined is not a function, or, null equivalents of that. Yeah. In Ruby, you have nil. Elm doesn't have any of those. It doesn't have a concept of null. So I said this in the talk, like Sir Tony Hoare has this great quote, he introduced the concept of null and he considers it his billion-dollar mistake because he thinks it's caused over $1 billion in economic damage.
Absolutely.
Yeah, and Elm just doesn't have it. Instead, if you want to represent the idea of, there's a potential absence of a value here, which is conceptually what null does, Elm has a way to do that in a way where the compiler is capable of checking for that and explicitly saying, oh, you need to handle that here. Like, you can't forget to handle it when you use it. It's been kind of an astonishing experience, but what's even more astonishing is that we're not the only ones who've had this. Like, whenever I meet somebody tells me they're using Elm in production, that's always the first question I ask is, how many runtime exceptions have you gotten? And so far, it's been 0 from everybody I've asked. This is,
Oh, that's cool.
I mean, honestly, that can't go on forever. I'm aware of this because you can still run out of memory and cause a stack overflow, right? There's just ways you can crash programs, like no matter what your design is. So I'm sure it's bound to happen sooner or later. But just the fact that it's gone this long without happening to me or anybody I've talked to is pretty impressive.
I mean, so you've mentioned a few times that the compiler really helps you out. I'd like to dive a bit more into that. I mean, we've had statically typed languages forever. Compilers always helped us, but how is that compiler really helping you out to make this experience such an amazing, awesome thing?
I'd say 2 things. One is the design of the language, and 2 is just that Elm is one of the first languages that's really focused on the idea of compiler as assistant, not just compiler as, something that generates the bytecode or generates the JavaScript.
Oh, okay.
So actually, Evan Czaplicki, the creator of Elm, he's done such a good job on this and has spent so much time thinking about how to give a good compiler experience that Elm is, I'm going to say, easily the most cited language for whenever another language says we want to try and make our compiler error messages better. I see this all the time now. They cite Elm as we want to be more like Elm. And it's not like, nobody could be doing this. I think it's just that Evan's the first person to say, I'm actually going to devote a lot of time and energy to trying to get this right. He actually gave a talk at UCLA a year or 2 ago to a room full of programming language authors about how to get nice, high-quality error messages. And Martin Odersky of Scala fame is in the audience taking notes. This is, it's really kind of on the frontier of how to get a good user experience from your compiler. So that's one aspect of it. And the other is just that the language's very design is around how can we have a really nice user experience where things don't crash. So some good examples of this are, so we talked earlier about null, the idea of having the sort of opt-in way of representing the absence of something where you sort of have to go out of your way to say this can potentially be missing. So you think about array access, right? You have an array of things in JavaScript and you can just say, bracket 5, bracket 7, whatever. And what it'll give you back is potentially undefined if something's not at that position. So in Elm, when you have the equivalent, you've got an array and you want to get something out of there, that's explicitly where it says, okay, this is one of those opt-in moments. This is where we can potentially have the absence of a value. And what that means is that you can't forget to check for what happens if the index is out of bounds. What happens if there's nothing at that position?
Oh, cool.
Right? And this is something where in JavaScript, it's just very easy to end up with an undefined there and just have that, filter through your program.
So when you say you can't forget to check that to make sure that there's a value there, what does that mean? Is that in the language or the compiler enforces you as the developer to handle that condition?
Both. So basically what comes back when you do an array get at a certain position is it's basically a container around the value you want. So let's say you've got an array full of strings. What you get back is not a string, it's a container wrapped around a string. And that container says, I've either got a string inside me or I do not. And so you actually have to do a second check when once you get that value to pull something out of that container. And there's basically a conditional that will let you say, okay, here's what I want to do in the case that there is a string in there, and then you can actually get the string into scope and work with it. Or here's what I want to do in the case where there is no string in there, and then there is no string in scope, you can't work with it. So the compiler then checks all of that and says, okay, like you have to have both of these branches, and you can't leave it out. And
nice.
Yeah, so I know that there's been some work in like TypeScript and Flow to do this with null checks, right? Where it's got this notion of you have to have an if statement that checks the conditional to see if null is being handled or not. But an important difference is that with Elm, that's actually baked into not only the language, but also all of the libraries and all of the APIs, across the board. It's not just for null, it's for basically everything. So all of these corner cases where something might be missing or something might be one of two different options or one of three different options, and they all work a little bit differently, this notion of you can't forget to handle it is just pervasive across the language. It's not special case to null. It's just everything works that way. And so that's how you can get from, things are better to things just don't crash.
That's pretty awesome. I want to take a second to kind of go up a little bit higher level and talk a bit about the architecture of Elm itself and how it all works. So I'm going to test your ability to describe things without a whiteboard.
No problem.
So how does Elm work? How does this all get packaged up? Well, first off, what do I need in my environment before you go into it? Do I need to go set up, Grunt and Gulp, and do I need NPM? Do I need to set up, 15 other JavaScript packages to get started? What do I need? And then once I have all that, walk me through what it looks like to compile a program. How does all that work?
Yeah, sure. So if you want to get Elm, the easiest way is just do npm install -g Elm, and then that'll just install everything for you. So Elm is very self-contained if you want it to be. So the compiler is just called Elm make, and you just say Elm make, you give it the name of your main file, and then it'll just spit out the compiled JavaScript. Actually, if you want, it'll even give you an HTML file that imports that JavaScript, so you can just have it all right there. That's not quite what people use for production. Typically, when people are using it in production, they, in practice, are still doing some amount of JavaScript interop, which means that they end up wanting to use stuff like Webpack or Grunt or Gulp to manage the JS side of that. So if you're doing a pure Elm project and it's got no JavaScript dependencies that you care about and you don't need any of that stuff, you can really just get by with just Elm make just the whole way through. But like I said, in practice, people tend to want to access, the JavaScript library ecosystem is much bigger than the Elm library ecosystem. So people end up wanting to do that in practice. But if you're just trying to get started, you don't need any of that. You can just start with, npm install -g Elm and then go from there without installing anything else.
Yeah.
As far as how Elm programs are put together, the basic interaction paradigm centers around three sort of central concepts, which is model, update, and view. So at your basic level, you have your model, and your model represents your entire application state. It's immutable. It's just one immutable value, and it represents everything that's going on in your application. And I really do mean everything. This is sort of distinct from, React or Redux or Flux or Angular, Ember, where you have sort of your application state is distributed amongst lots of different places. You have, maybe Flux stores, or you have stateful components.
Yeah.
So Elm does not have a component system on purpose. There's no way to store state anywhere other than the model. And this has some really interesting implications, in particular for debugging. But basically, you take that model, this immutable value that represents your entire app state, and the Elm runtime, which is sort of the JavaScript that gets generated to make all the engine run, will just take that model and pass it to a view function that you define. So you write this view function, and all it does is it takes the model, and then it returns some virtual DOM. That is a description of how you want the page to look. So the argument is the entire application state, and the return value is here's how I want the page to look. Then you have user interaction. People click on the page, and then based on that user interaction, it calls this update function that you run. And update function's job is to take the old model, the previous application state, and a message describing what the user did, and then use that to return a new application state. And again, this is just one immutable value. It's just like, here's everything. Here's the entire state of the world.
Yeah.
And then it gets that new one, calls the view function on the new one, and then that gets a new description of how the page should look. And then from there, you're sort of off to the races. That's, I'm sort of breezing through this, but that's the high level, the whole idea.
Sure. So it's basically events flowing through the system. It's very reactive, and it's just taking it and binding that new event to the model, or taking that model rather and binding it to the view, and that's how things.
Yeah, that's all there is to it. it's very consistent.
Yeah, nice. So a couple questions come. Yeah, that's all there is to it. So a couple things come to mind. So you have this Elm code and it gets compiled to this runtime. What's that size look like? Is that pretty heavy?
Yeah, it's a great question. I would say it's currently pretty medium, and it's about to get pretty light. So right now, if you do to do MVC, like Elm to do MVC, it's smaller than React to do MVC after like minification and gzip. That's even though it's including basically immutability library, like persistent data structures are built in, and also state management is built in. So in practice, React to do MVC doesn't have state management like Redux or Flux, and it also doesn't have an immutability library built in. But most people who are using it in production tend to want one or both of those as they scale and get bigger. That's actually going to change in the next release of Elm. It's most likely, the release isn't out yet, so obviously anything's still subject to change. But that's been actually a big focus right now is on asset management and on things like dead code elimination. So the idea of here are these functions, like the HTML library has helper functions for, button, form, input, all these different things. But in practice, you don't end up using every single one of those. So dead code elimination is basically saying, oh, you're not using all these functions. Let's just throw them out. Let's not even keep them.
Sure.
And so I don't know what the exact numbers are, but what I've heard is that preliminary numbers suggest that it's like really small, especially considering that you're getting an immutability library and a state management library. I expect to be a pretty exciting release for people who are really constrained on bandwidth.
Okay, so the next question that comes up for me with what you describe is if you're keeping the entire state for an application and it's completely immutable, with every state changing event you have to completely recreate the immutable state. That seems like a huge performance hit to me. What's the performance like using Elm?
Yeah, so the key there is that these are using Elm's built-in persistent data structures. So they're actually, you're not cloning the entire thing every time. It's just, syntactically, you're expressing it as like, here, build this whole new thing from scratch. But actually, under the hood, what it's doing is it's just, it's doing lots of node sharing, and it's like only actually changing the stuff that needs to change.
Okay.
Performance-wise, Elm actually benchmarks better than React, Angular, and Ember. So there's a blog post on the Elm website that's basically going through like here are the methodologies we used and like a lot of details about like here's how we compared apples to apples on rendering performance. There's also some pretty cool tricks that Elm can do because the entire language is built out of immutable values and pure functions. Like you can't write an Elm function that has a side effect. So it unlocks these really cool performance optimizations that are safe to do in Elm that are not safe to do in the general case for React and other libraries. For example, batching your view functions. So you can actually, and not you can, but actually just does this for you. Elm will call request animation frame and only call your view function basically like right before it's time to render. 60 frames per second, it doesn't actually get you anything to call that view function on every single time the model updates. It only gets you something to call the view function on the current model whenever it's about ready for the browser to render.
Okay.
And so that's what Elm does. It just says, okay, well, we'll just only call the view function, and that happens.
Oh, nice.
In React, you could do that, but since view might have a side effect, that could actually cause some pretty nasty bugs. But in Elm, at compile time, it's guaranteed that there are no side effects, so it's definitely safe to skip that. Whenever you want to.
That's really cool. There's another thing I wanted to ask you about, and that was, I think I mentioned at the very beginning, the debugging experience with Elm. I was kind of blown away about. But this whole idea of immutable state and then just having this model flow through the system and then be able to do these updates gives you some really interesting capabilities with debugging. Could you walk through what the developer experience is like debugging an Elm project?
Yeah, totally. So one thing I didn't mention earlier is that when the user does interactions like clicking or typing in a text field or something like that, what happens is that you specify this in terms of messages. And a message is a piece of data that says, here's what the user did and here's whatever information is necessary to perform the update. So let's say you click on a button, it might just be, hey, the user clicked on the submit button. If the user's typing, it might say, hey, the user typed in this text field, and by the way, here's what they typed. And so since your update function is written in terms of these messages, what the debugger can do is it can actually just display, and it does display, just a list of all the messages that are flowing through your system. And you can just step back in time and time travel and say, okay, when this message came in, what was the state of the world? How about when this one came in? How about when this one came in? And you can look at that, and also you can look at the model, which again is your entire application state. So you can just kind of expand out the tree and just look at, okay, what were all the values in my system at that point? It's like you have a watch on everything. And again, you can approximate this thing by, like Redux, which is actually based on the Elm architecture. It was Dan Abramov was looking for a way to implement time travel debugging for a conference talk that he had submitted, and he was looking around. He's like, "This is really hard to do in React," and he found Elm and was like, "Oh, they're doing it. How are they doing it?" And so he sort of based Redux on that. But there is this really important difference between having it on an opt-in basis versus having everything built around it, right? So like if you're time traveling in Redux, all of your Redux state comes with you. But everything else that's, like your stateful components and stuff like that, it's just not aware of those. It can't, those are not part of the picture.
Yeah.
Whereas for Elm, it's really the whole application. The fact that not only all the stuff you write, but the entire Elm ecosystem is built around this means that you get this whole different level of like when I'm going back through time, it's really going back through time.
Yeah, you did in the presentation that I saw you do, you exported the entire event order and then brought it into another browser and kind of recreated that entire state, and gave you some really interesting things. If I'm working on some kind of feature branch that has a bug in it, I can bring in that state and give it to another developer who can then check out my branch and be able to recreate it. That was a really cool experience for a developer to be able to get to that exact condition that raised that bug.
Yeah, exactly. Yeah, I mean it's like reproducing bugs is a surprisingly time-consuming experience when the bug is hard to track down.
Yeah, it is.
And just being able to say, look, here's the file, just import it. Yeah, definitely a night and day difference.
So I'm going to throw you for a loop a little bit here, maybe throw you for a loop. But what so where are the sticky parts of Elm? It sounds like a great story, and it sounds like it's going to be an amazing experience for me to bring it into my project. But where's the but? There's got to be something in there that's the sticky parts, the tricky parts, the parts that I need to overcome and learn about. What are those with Elm?
I'd say a couple things. So the biggest one is that basically Elm's approach is to say, okay, we're going to make a really clear, bright line distinction between Elm land and JavaScript land. And so Elm is saying like, okay, we have these primitives and we're building on top of these primitives, and that lets us enforce these guarantees that give us this really good experience. The trouble is Elm doesn't have a complete wrapper around like every single thing you can do in the browser that's like done in this nice way yet. So that means that you end up doing JavaScript interop for some, maybe surprising things. So there's, the part of your application that's written in Elm, and then sometimes you'll come across something where you're like, where's the Elm library for this? Oh, it doesn't exist yet. And actually, not only does it not exist yet, but this is just not something you can express in Elm at this point. So I know in particular, some people who've been doing things around content editable, like people who are making WYSIWYG editors, like text editors and stuff like that. That tends to be some pretty DOM mutation heavy stuff.
Right.
And at this point, Elm just doesn't have a lot of libraries, a lot of support for like really digging into the DOM and doing like manual manipulation. And so when you get to that point, you just end up going straight to JavaScript interop. And, obviously that's not as good of an experience as, when you're building a more general purpose application. You can kind of stick more to just, Elm for 95, 100% of the thing.
You said a second one, but I want to ask you a quick question about that.
Yeah, sure.
And let you come back to the second one. So what does that JavaScript interop look like? I mean, you're in your Elm application. How are you wiring in? I think you used a calendar example for example, in your talk. How do you wire in that JavaScript call into another library?
Yeah, so the way Elm talks to JavaScript is basically the same way that it talks to servers, which is to say all you do is you send immutable data out to JavaScript, and then JavaScript can send some data back to you.
Just like calling a function.
Well, different from calling a function in one important way, which is that you're only allowed to do it at certain points in your update function, like at the end of your update function. So again, Elm programs are built out of functions that don't have side effects. And since JavaScript functions can just have side effects, so another way in which it's similar to talking to servers is that basically the way that you do async, the way that you do effects in general in Elm is that you return a value from your update function. So update returns, here's my new model. And then it can also return, here are some effects that I want the runtime to execute, and like what I want it to do when they're done. And so you do JavaScript interop the same way, where you would either say at the end of update, okay, I want you to do this HTTP request, and when it's done, send me back a message to update, with what came back. Same thing. So in that way, you have the same error handling characteristics as you do with servers. You don't have to worry about the JavaScript code sort of like sneaking in and breaking your guarantees.
Gotcha.
But it is more work.
So you said one of the second way that you thought that Elm, there could be a tricky point with Elm.
And so that would basically be the server side story. So if you're writing JavaScript, you can do the same language on the client and on the server. In Elm, you can't yet. So like theoretically, in the sense that Elm compiles to JavaScript, yes, you can run Elm code on Node on your server, but there is no ecosystem for it, right? There's no like HTTP web server library. There's no database access. There's just nothing. And this is by design, because basically the choice was sort of, should we split focus and go down the browser path and on the server path, or try to do a really good job on the browser and really get that solid, and then move on to the much bigger project that is the server. And that road seemed to make the more sense.
Yeah, it makes sense.
But that does mean that for right now, if you want to have the same language on the client and the server, you just can't do that with Elm.
Okay, so one other question. Whenever you're exploring another language, you kind of want to know about the community and the ecosystem. What's the ecosystem look like with Elm? What's the community look like?
Yeah, great question. So community is awesome. It's like one of my favorite parts. I mean, so we had ElmConf last year in St. Louis. It's going to be coming back again next year. It's the day before Strangeloop. It's sort of attached to Strangeloop. We're about to have Elm Europe in Paris in June. I think actually there are still tickets left for that, but very excited about that. But I just I love meeting community members in person, because they're just like really nice, really smart people. And there's just a great culture of like kind, helpful, thoughtful, friendly people. I always think about programming language communities and what's it like if you're a beginner walking into this community? Is this going to be people who are just like, beginners, so annoying, they don't know anything? Or is it like, oh, hey, welcome, let me help you out, let me answer your questions? And Elm is definitely the second kind.
That's cool.
As far as the ecosystem goes, I would say that it is much smaller than the JavaScript ecosystem, but also much higher quality, like much more reliable. And that's for a few reasons. The biggest one is that Elm package, so Elm has its own package manager completely separate from NPM, is really strict about a couple things. One is that you can only publish Elm code to it. So if I make a new project and I'm like, here's some Elm code, great, and I hit publish, it's like, great, thanks, your package is now published, people can use it. As soon as I do JavaScript interop in that package, I can no longer publish it. It says, nope, sorry, can't do it. So what that means is that now the entire ecosystem is all pure Elm stuff. It's got all the guarantees. There's no asterisk. There's no, this might break at runtime, on the JavaScript side. It just, it's all Elm. That does, of course, mean that, it's going to be smaller, right? A good example of this is like people wanted a hashing function, right? Like an MD5 or a Murmur 3 or, and somebody's like, oh, hey, can I just wrap, the JavaScript implementation? It's like, nope, you got to write that hashing function in Elm. And so, and at first people were like, oh, that's too much work. I'll just do JavaScript interop. But then eventually somebody was like, okay, I'm just going to do it in Elm. And so now you have hashing functions written in Elm on the package.
Very cool.
So that's one reason. Another cool benefit of that, by the way, is that the package manager enforces semantic versioning automatically. So if I publish that package that I wrote in Elm, and then I'm like, oh, I'm going to delete this function, or I'm going to change the arguments around, and then I try to publish that as 1.1, it'll say, nope, that's a breaking change. I saw what you did there. I can tell that you changed the API. You have to bump the major version number. You have to publish that as 2.0. So it makes upgrading a lot nicer than the experience we've had with NPM. I heard a great quote from somebody actually in London after QCon, which they said, I didn't switch to Elm because I was unhappy with React. I switched to Elm because I was unhappy with NPM.
Oh, wow.
Yeah, and I can totally appreciate that. It's a very different experience when that's your whole package ecosystem. And the other thing is just that culturally, Elm has this, the package community has this value that turns out to be really good, which is that it's the way things are named. So there's this cultural thing where you're really supposed to name packages after what they do. So you have Elm CSS, which is a CSS preprocessor. You have Elm Test, which is the testing library. And pretty much 95+% of people use that one thing. Well, what's interesting about this is that what that means is when somebody goes to create a new library, the first thing they do is they're like, oh, I want to name it the obvious thing. What's the obvious name? And so they'll go and look and see if that already exists. And so they're more likely to just be like, oh, this already exists, I'll contribute to it. And so it's actually kind of weird for you to say, oh, I'm just going to make another version just because I want to do things a little bit differently.
That's great.
Yeah. And so it ends up having this effect where this sort of, people use the term JavaScript fatigue, where you just have a million different options to choose from and you don't know which one.
Yeah.
Part of that is that the Elm community is smaller, granted. But the other part is that, when people make something new, they're sort of culturally drawn to trying to contribute to the existing thing rather than splitting off and making an alternative. And so as a newcomer coming in, you're more likely to just be like, oh, there's just one obvious, popular way to do this, and there aren't just a bunch of different things that I have to spend even more time deciding between.
Yeah, that's very cool. That's really cool, actually. Thank you for the time, Richard, for chatting with us. If you enjoyed some of the stuff you've heard and you want to learn more about Elm, make sure to check out Richard's book. I think you've got a MEEP out that's got 3 or 4 chapters out. Is that right?
5 right now. I'm
5.
Almost done with chapter 6.
Very cool. So check out his Elm in action. You can catch his video for QCon London. I'm not sure when it's going to be published, but it'll be out in the next at least 3 or 4 months because everything's published within 3 months. And also check out ElmConf in Europe or in the US in St. Louis if you want to learn more or dive into some deeper conversations. So Richard, thanks for chatting with us.
Yeah, thanks for having me.